All right, so the first question for this problem, eventually we're going to graph it, but the first question is, what is the EBA? And remember, for the EBA, you want to think, does the graph approach something as x goes to positive or negative infinity? And as x goes to positive infinity, this whole piece here is going towards 0 because the degree of the denominator is greater than the degree of the numerator. And it also happens that this piece is going towards 0 because 1/2 to a huge number is going to get closer and closer to 0. However, if we think about where as x goes to negative infinity, this piece again still goes towards 0 because bigger degree in the bottom. But this piece, this first term, will not go towards 0. It, in fact, will go towards, if I think of 1/2 even to the, let's even say 100,000. That's, sorry, not 100, negative 100,000, putting in towards negative infinity. That's the same as 2 to the 100,000, so getting very big. So in other words, as x gets huge from both positively and negatively, this is going towards 0, but this piece is going towards 0 when it's going towards infinity, but it's going towards infinity as it's going towards negative infinity, which is really how this graph here behaves at the ends. So the EBA is y equals 1/2 to the x. So remember when we talk about an EBA, we are really thinking about what is it going towards at both ends. And it is going closer and closer to 1/2 to the x, or how that graph behaves. So that's my EBA. Okay, vertical asymptotes is always where anything in a denominator equals 0. It'll have that explosive behavior. So this was the EBA. The vertical asymptote was x equals 5. And I'm noticing that the degree of that to the 4th, so it will not change sign on either side of that. And no terms are canceling, so there are no holes in the. So now another question is, does this intersect the EBA? And to figure that out, this graph is in a perfect form to determine that. I'm going to set the original function equal to the EBA, because again, we want to see, does it ever cross? Well, when that happens, this piece goes towards 0. So you just have this negative x squared minus 1 over x minus 5 to the 4th equals 0. And I can multiply both sides by negative 1, but in the end, the only way this equals 0 is if x squared minus 1 equals 0, or x plus 1, x minus 1 equals 0, or x equals plus or minus 1. All right, and let's just find the whole point. So when I plug in 1, and all I have to do is plug it, since that's where it's crossing the EBA, I can just plug it into the EBA. When I plug in 1 to 1/2 to the x, it's just 1/2, so 1/2. And the other point is negative 1, 2. Okay, so those are good points to know. And let's keep, the other thing that'll be helpful for my graph is a y-intercept. So the y-intercept is when x is 0. So 1/2 to the 0 is 1. So it's going to be 1 minus a negative 1 over negative 5 to the 4th. So it's going to be 1 plus 1 over 5 to the 4th. So just over 1. All right, so let's get to graphing this. And let's just do all that we know here. And then we can figure out if we need to do a little sign analysis. All right, so it's the vertical asymptotes are at 5. The vertical asymptote. And then the EBA is 1/2 to the x. So at negative 1, it's 2. The it's 2. The y-intercept is 1. Then at 1, it's 1/2. I'm just going to dotted line this. Now remember, we know some points on the graph, though. We know it crosses the EBA at negative 1, 2, so that's actually a point on the graph. It also crosses at 1, 1/2. So that's a point on the graph. And the EBA is a little bit more than 1. And so one thing to note, and we need to figure out, it may be helpful to figure out when it's above or below the EBA. And to do that in this case, the EBA is 1/2 to the x. So I really care about what's happening with x squared minus 1 over x minus 5 to the 4th. And I actually kind of know what's going to happen just looking at the graph, but this may be helpful. So if I put these numbers on a number line, -1, 1, and 5. Actually, let me erase that a little bit. That did not look nice. Okay, let's do this again. So -1, 1, and 5. So if I put in a number to the right of 5, just into this piece here, it would be positive. But because I'm subtracting this quantity here from the EBA in the function, that means greater than 5, I'll be below the EBA. And it's not changing sign across 5 because it's to the 4th, so it will still be below the EBA. Across 1, so for example, I put in 0, this piece, this whole quantity here will be negative. So minus and negative in the original functions means I'm going to be adding to the EBA, so it's above. And then it's going to switch signs. So, and this is all above or below the EBA. So, and I said in the problem that you don't have to find the x-intercepts. In fact, it's too hard to do so. I know it's not changing sign across the vertical asymptote. And because I hit my y-intercept above, it makes sense that I'm above the EBA. And then remember at the ends, I have to get closer and closer to my EBA. So that's what that graph there looks like. It's kind of a tricky one. But having these points of intersection and having the y-intercept and knowing it's not changing sign across the vertical asymptote and knowing that at the ends it goes toward the EBA should be enough to get you that general shape.